Let's do one more example of calculating a left, right, and midpoint sum. Here we're asked to approximate the net area bounded by the graph of f and the x-axis on the interval pi over 2 to pi. And our function is f of x equals sine of 2x, and we want to estimate this area using 4 rectangles. Now, as we can see over here on the left, the graph of sine of 2x is clearly below the x-axis on the interval from pi over 2 to pi. Not one part of that graph lies above the x-axis. That means that our sums, when we find them, will be negative because the entire portion of the graph is below the x-axis, so that's going to give us a negative area. The first thing we need is the width of our rectangles. The total length of our interval is pi minus pi over 2, and we want to divide that into 4 equal width rectangles. That means that the width of each rectangle will be pi over 8 units. And as you can see, we already have our scale of pi over 8 units marked off on our x-axis. The leftmost endpoint is pi over 2. Pi over 8 units from that is 5 pi over 8. Pi over 8 units from that is 3 pi over 4, and then 7 pi over 8, and then pi. All right, let's calculate the left sum. The left sum is equal to delta x, which is pi over 8, multiplied by the sum of the heights of our rectangles. To get the heights of our rectangles, we'll evaluate the function at pi over 2, 5 pi over 8, 3 pi over 4, and 7 pi over 8. Now we'll use Desmos Scientific to help us with this calculation. In the scientific calculator, we'll plug in f of x equals sine of 2x, and then we'll evaluate sine of 2x at pi over 2, 5 pi over 8, 3 pi over 4, and 7 pi over 8. Add those sums together, and then multiply by pi over 8. And when we do this, we want to make sure we're in radian mode. And that calculation should give us negative 0.948. Now let's work on the right sum. The formula for the right sum follows the pattern for the formula of the left sum. So we'll need delta x, which is pi over 8. And again, that'll be multiplied by the sums of the heights of our rectangles. But because this is a right sum, we won't use the leftmost endpoint to determine the height of our first rectangle. We'll use the next grid point. So to get the heights of our 4 rectangles, we'll evaluate the function at 5 pi over 8, 3 pi over 4, 7 pi over 8, and pi. Again, we'll plug all this into Desmos Scientific and perform the calculation. And it turns out that when we round to 3 decimal places, the left sum and the right sum are exactly the same. Now, that doesn't necessarily mean that that's the exact area between this curve and the x-axis. So let's look at a midpoint sum now. For the midpoint sum, the heights of our rectangles will be found by evaluating the function at the midpoints of each of our subintervals. That means the height of each one of our rectangles will be evaluated at 9 pi over 16, 11 pi over 16, 13 pi over 16, and 15 pi over 16. And again, using Desmos to help us calculate this, we get approximately negative 1.026. Again, notice that each one of our estimates here are negative, and that's because the entire graph of sine of 2x lies below the x-axis on the interval from pi over 2 to pi.